In example 1, there are two functions. There are two pieces to this graph. The first function is a linear function. The second function is also a linear function. So I am going to have two lines. Two lines with a certain restriction, that is, x is less than 0 and x is greater than or equal to 0. So less than for us is going to be to the left. Greater than is going to be to the right. Now notice it is x, so I'm restricting my domain. So x is less than 0, so this first function will be to the left, and the second function is greater than x, so it's going to be to the right. So since I'm restricting this graph at 0, I'm going to take a highlighter and highlight this middle section here, which is x at 0. So one of the functions will be over here to the left, and one will be on the right-hand side. And my goal is to just graph it, and only graph it exactly in that spot. Okay, here we go. And I'm going to do many examples, but one more thing I need to go over. This is not equal to, this is equal to. So if it is not equal to, you will have an open circle. And if it is equal to, you will have a closed circle. So it's very similar to graphing on a number line in terms of equal to. If it is equal to, you will have a closed circle. If it is not equal to, you will have an open circle. Okay? So I'm going to start off right now by graphing this first function. So this first function has a y-intercept of -4, right? So I'm going to go down at -4. I'm going to make an open circle at -4 because when I hit the line, I cannot be equal to 0. I can only be less than 0. Okay, I'm going to take a pencil. My slope here is 1. Okay, my slope here is 1. So then I'm going to go up 1 over 1, up 1 over 1 in this direction. But can this function exist on the right-hand side? No, it can only exist on the left-hand side because it's all the values that are less than 0. So what I'm going to do is I'm actually going to graph this function to the left because in the problem it strictly says that it can only be less than 0. So everything that is less than 0 is from this open circle all the way to the left-hand side. And I can actually put an arrow down because left would go all the way to -infinity. And this first graph is check, finished. So if you were, for instance, sometimes it's easy almost to just graph the whole function and erase what you need. Just make sure that whatever you have at the end of the graph here, that you erase this because it can only be to the left of the highlighted region, which it gives it to us right here. So two pieces. The first piece to the left, check, done. The second piece has a different equation. I'm going to actually be at +4, but notice that I am now going to put a closed circle because I can actually be equal to 0. So I'm going to actually put a huge closed circle right at +4 because I can actually equal 0 and actually hit at 0. Now, this slope is -1, so I don't go up 1, right 1, up 1, right 1. I'm going to go down 1, right 1, down 1, right 1, down 1, right 1. And notice how I didn't grab my pencil this time. I actually did and put it down real fast, but I didn't need my pencil this time because if I graph the slope to the right, I actually need this to be to the right-hand side, and I can just keep it and go. But since it exists on the right-hand side, I cannot graph anything on the left-hand portion of this, and I'm going to go ahead and fill out the points as you go through. So the whole goal of this is to take two different graphs and only take certain pieces restricted at a certain number and graph them. One will be on the left-hand side, and one will be on the right-hand side. Number 2. If I'm looking at number 2, let's kind of go ahead and see what goes left and what goes right. So the first function is linear. Okay. The second function is quadratic, so I'll have a line and a quadratic function together again. I can zoom in a tad. I'll zoom in and I'll zoom out. Come on. Okay. The first equation is greater than, so x greater than. Greater than is to the right, which means less than is going to the left, and less than left, they both start with an L. Less than left, greater than right. Which one will be closed? The top one will be closed, which means the bottom one will be open. Now, what you can do for this first part, I'm going to show you two different ways to solve for the evaluating questions. You can solve them now, or you can solve them later. It does not matter. I want you to pick the one that's easier for you. So if you look at this, this says -2. Is -2 greater than or equal to +1, or is -2 less than 1? So therefore, you put it into the equation. You substitute the value into the equation that it fits. So it fits the one on the bottom. So I'm now going to put -2 squared plus 3. So I'm going to put -2 in for x and then solve. -2 squared is 4. 4 plus 3 is 7. So my first answer is 7. However, if you look at the next example, 6. Is 6 greater than or equal to 1 or less than 1? 6 should be what than 1? Greater than or equal to 1. Therefore, I put it into the what equation? Top or bottom? So now, 2 times 6 plus 1, which is 12 plus 1, which is 13. So you put the number into the equation that it fits. If -2 is less than 1, it goes in the bottom equation. If 6 is greater than or equal to 1, you put it in the top equation. But what if I'm given 1? Is 1 greater than or equal to 1, or is 1 less than 1? Greater than or equal to, because I'm actually able to equal 1. So therefore, I will do 2 times 1 plus 1, which is 3. 2 times 1 is 2. 2 plus 1 is 3. Okay, you can choose to do this section here before, or you can choose to do it after you have the graph and you can actually see the numbers and you just pull the numbers off. It does not matter. I believe this is easier. I would always do this first and kind of make sure that those are the points on your actual graph as you graph them. Now I'm going to zoom out. Okay, now I need to know where I'm restricting it. I need to restrict it at the number 1. So what I'm going to do is I'm going to zoom out. I'm going to move it over. Oh, I got to zoom out more. Come on. Okay, that should be okay. I can do this. Okay. I'm going to restrict it at 1. So I'm going to highlight at +1. And let's just start with the first graph. Okay. So my very, very, very first graph is a linear equation, right? And I want this to the right of my highlighted region. Now, my y-intercept is 1, which actually ends up being to the left of the line. I don't want it to the left of the line, but I'm going to use it right now in order to get me across the line to the right. So now my slope is 2. So I'm going to go up 2 over 1, up 2 over 1, up 2 over 1, and I'm only going to graph this function to the right of 1. That first one is checked. So just to make sure, is there a linear function to the right of 1 and a closed circle? Yes. Linear equation, closed, and to the right, check. What I need to do is take this up 3, or use Desmos and see the graph of it, up 1, 2, 3. I can plot that point because I know for sure that I can stay to the left of it, so that's perfect. So let's keep graphing left. So over 1, up 1, back to the vertex, over 2, up 1, 2, 3, 4, because 2 squared is 4, and then now this will end up going off, and those are the only points that I have. Now, is this finished yet? Is there a piece to the puzzle that's not there? Yes, so I need to implement the open, right? And then notice how I've graphed the parabola here and the line here, but there's a gap here. You need to completely fill all gaps up. So here, I'm going to go over 1, up 1, and right here I'm going to make it open, connect my parabola like I normally would, and it will be open right above the closed one. So there's the parabola, open, and then the linear function takes it home.